Hi, today I'll be working on the May 24 math paper, paper 4, variant 1. Before we start, I hope you can subscribe to my channel. Question 1a says that the table shows the areas in square kilometers of the 4 largest rainforests in the world. Now the I part asks you to find the area of the Valdivian rainforest as a percentage of the area of the Amazon rainforest. So for this, we divide the Valdivian rainforest by the Amazon rainforest and then multiply that fraction by 100 to convert it to a percentage. So in this case, the Valdivian rainforest is equal to 250,000. And we divide this by the Amazon rainforest, which is 5,500,000. Now you multiply this value by 100 to convert it to a percentage, as you can see over here. And the final answer when rounded to 3SF would be 4.55. Now II says to write in its simplest form the ratio of the areas of the rainforest Valdivian to Atlantic to the Congo. So Valdivian is 250,000 and the Atlantic is 1,315,000 and the Congo is 2 million. If you break these down into its component fractions, prime factors, 250,000 would be represented as 2 to the power of 4 times 5 to the power of 6, and 1,315,000 would be represented as 2 to the power of 3 times 5 to the power of 4 times 263. Now 2 million can be represented as 2 to the power of 7 times 5 to the power of 6. Now if we see there are two common prime factors, 2 and 5, which are common in all three numbers. So in this case, if we divide all three of these values by the HCF, i.e. the highest common factor, we can get the simplest form of the ratio. So if we first divide all of them by 2 to the power of 3, divided by 2 to the power of 3, divided by 2 to the power of 3, we get this cancelled off in the middle value because 2 to the power of 3 divided by 2 to the power of 3 is 0. Now if we divide 2 to the power of 4 by 2 to the power of 3 in the left hand side, we get 2 to the power of 1 because for the rule x to the power of a divided by x to the power of b is equal to x to the power of a minus b. Now on the right hand side, if we initially had 2 to the power of 7 and we divided that by 2 to the power of 3, we get 2 to the power of 7 minus 3, which is 4. Now if we divide these three numbers further by 5 to the power of 4, in the same way as before, we can cancel off 5 to the power of 4 in the middle term because it's the same number and any number divided by itself is 0. On the left hand side and on the right hand side, we can reduce 5 to the power of 6 to 5 to the power of 6 minus 4, which is 5 squared. So our final answers would be 2 times 5 squared, which is 2 times 25, which is 50 for the Valdivian, to the Atlantic, which is 263, to the Congo, which is 2 to the power of 4 times 5 to the 5 square, which is 16 times 25, which is 400. This is our final answer, 50 to 263 to 400. Now for triple I, the Amazon rainforest has 60% of its area in Brazil and 10% of its area in Colombia. 43 and the third percent of its remaining area is in Peru. Find the percentage of the Amazon rainforest that is in Brazil, Colombia, and Peru. So in this case, if we first find the remaining area, which I'll write as RA for now, this would be equal to 100% of the Amazon rainforest minus the area that's in Brazil, which is 60% of the Amazon rainforest, minus 10% of the Amazon rainforest, since that's in Colombia. This value, which is 30% of the Amazon rainforest, represents the amount of rainforest of the Amazon that's neither in Brazil nor in Colombia. And out of this 30%, 43 and the third is in Peru, which means that Peru would be equal to 43 and a third percent of 30% of the Amazon rainforest, which is equal to 13% of the Amazon rainforest. Now the percentage of the Amazon rainforest that's in Brazil, Colombia, and Peru would be equal to adding all three of these values. So 60% plus 10% plus 13%. So 60% plus 10% plus 13% is equal to 83%. And this is our final value. Now For IV, the area of the Amazon rainforest represents 27 by 50 of the total area of rainforest in the world. Calculate the total area of rainforest in the world and give your answer correct to the nearest 100,000 kilometers. So the table in the previous question established that the Amazon rainforest area is equal to 5,500,000. Now this can be represented as 27 by 50 of the total area of rainforest in the world. So if the total area is equal to X, this means that 27 by 50 times X is equal to 5.5 million, i.e. the area of the Amazon rainforest. So in that case, X itself, i.e. the total area of rainforest in the world, would be equal to 5,500,000 divided by 27 by 50. Now the exact answer for this would be equal to 10,185,185.19 rounded to 6, 6, 7, 8, 10 SF. But the question asks you to round it to the nearest 100,000 kilometers. So you check the 100,000 place, which is equal to 1. Then you check the digit that's to the right of it, 8. Since 8 is bigger than 5, this means that you add the 100,000 digit by 1 and convert all the digits to the right of it to zeros. So this would be equal to 10,200,000. And this in turn would become our final answer over here. Now V says that in the world, 60.7 hectares of rainforests are lost every minute. This means that if we write it as in a minute, we lose 60.7 hectares, which means that in 1 hour, we lose 60.7 hectares times 60. Because if we lose 60.7 hectares every minute, and if 1 hour has 60 minutes, then we lose 60.7 times 60 hectares of rainforest every hour. Now every day would be equal to the amount lost in every hour, 60.7 times 60 times 24, since in one day there's 24 hours. Therefore, in 365 days, which is what the question is asking us, it would be 60.7 times 60. Now this times 24 and this times 365. So this would be rounded to approximately 319,000,000. But the question asked you to give your answer in standard form, which means k times 10 to the power of n. So we take the first few significant figures, 3, 1 and 9. Now to convert this to standard form, we put a decimal place between 3 and the 1. Since 31.9 would not be equal to k, since k has to be within the inequality of 1 is less than or equal to k, which is less than 10. Now 31.9 is bigger than 10, therefore it does not fit for the value of k, I mean the inequality range of k. 3.19 does fit, therefore the standard form of this answer would be equal to 3.19 times 10 to the power of n. Now the question is, what is the value of n? If we write down again the exact same number, 319,000,000, and you put the decimal place between the 3 and the 1, and you put the actual decimal place, which should be after the last 0, because that is where it naturally should be, since after this 0, all subsequent values are just decimal values of 0 recurring. So to find how many digits the decimal place is shifted, which represents how many times by 10 this number is multiplied, 3.19, we check it, 1, 2, 3, 4, 5, 6, 7. Therefore, 3.19 is multiplied 7 times to get our final answer. So our final answer is 3.19 times 10 to the power of 7. Now B says that the Amazon River has a length of 6,440 kilometers, correct to the nearest 10 kilometers, and the Congo River has a length of 4,400 kilometers, correct to the nearest 100 kilometers. Calculate the upper bound of the difference between the lengths of the Amazon River and the Congo River. So if the difference would be equal to the Amazon minus the Congo, and we want a maximum difference as big as possible. This means that we have to make the Amazon value as big as possible while making the Congo value as small as possible. This ensures that the difference between the two is increased, since you're stretching the value of the Amazon while reducing the value of the Congo. So to make the upper bound of the Amazon River, i.e. the biggest possible value of the Amazon, would be equal to its actual value, like rounded value, 6440 plus, and we take the thing that is rounded to the nearest value of, which is 10, plus 10 divided by 2. Now we subtracted by the lower bound of the Congo. And since the Congo is equal to 4400 minus, now we check what is rounded to the nearest value of, which is 100, and we divide that value by 2. In this case, we get 6445 minus 4350. And our final answer is 2095. Question 2a says, on the grid, draw the image of triangle T after reflection in the x-axis. So as you can see, this is our x-axis. So since it's a reflection in the x-axis, the x-coordinate of each point remains the same, while the y-coordinate becomes its negative value. So in this case, as you can see, for this point, its x-coordinate is 2, while its y-coordinate is negative 1. So the x-coordinate of the image point would be also 2, while the y-coordinate would be positive 1, since negative of negative 1 is positive 1. Now, for this point over here, the x-coordinate is 1, while the y-coordinate is negative 3. So since the x remains the same, that's equal to 1, and y becomes positive 3. Now, for this point, x-coordinate is 5, while the y-coordinate is negative 3. So the x-coordinate of the image would be also 5, while the y-coordinate would be positive 3. So, with these 3 points drawn, we can now just draw straight lines between them to represent our triangle image. That's part A solved. No, not part A, sorry, part I solved. Now part II says to draw the triangle T after a translation by the vector -5 and -2. So for a vector, the upper value represents the x units and the bottom value represents the y units. If the x value is positive, this means that you're shifting the triangle or the object or the shape essentially by x units to the right. This is when it is positive. And if the x value is negative, then you shift it to the left by x units. As for y, if it's a positive value, you shift it up by y units. And if it's negative, you shift it down by y units. So in this case, as you can see, it's -5 and -2, which means that the x value is negative and the y value is negative. Ergo, it's being shifted left and down. So it's being shifted left by 5 units and it's being shifted down by 2 units. So if I just drag this and move it slightly up for us to reference when drawing our triangle, we can now take any of these points, for example this topmost point, and draw its image by going 5 to the left, 1, 2, 3, 4, 5, since that is how many units to the left it's being shifted. Then shift it down by 2 units, 1, 2. This is the image point for our first point. Now for our second point over here, 1, 2, 3, 4, 5, 1, 2. This is the image of a second point. For a third point, 1, 2, 3, 4, 5, 1, 2. Now with our third point drawn as well as our first two, we can now draw straight lines between these points to draw the image of a triangle. This is our part I answer solved. I'll just erase this. Now triple I says to draw the triangle T after an enlargement by scale factor -12 with center -1, 1. So let's first draw out the center of this triangle, which is center of enlargement of this triangle, which is -1, 1. So it's over here. This is our center of enlargement. Now the next step is to see the scale factor. In this case, it's -12, which means that it becomes inverted and its size becomes half. So in this case, if we take this point over here, the topmost point, and we find the distance between it and the center, this would be equal to 1, 2, 3 to the left, and 1, 2 up. So 3 to the left and 2 up. Now the half of these two would be equal to 1.5 and 1. So you shift the point from the center to its image point by going 1.5 to the left, and 1 up. This is the position of the image of our point. So we take the distance between any point of the triangle and the center, and then divide that distance by 2 and travel that same distance from the center to get the position of our new image point. So in this case, if we take this bottom point over here, for instance, that is the distance between it and the center is 1, 2 to the left and 1, 2, 3, 4 up. So its image would be 2 divided by 2 to the left, which is 1, 1 to the left, and 4 divided by 2 up, which is 1, 2 up. This is the position of our second point. As for our third point, if it's over here, the distance is equal to 1, 2, 3, 4, 5, 6 to the left, and 1, 2, 3, 4 up. So its image would be 6 divided by 2 to the left, which is 3 units to the left. So 1, 2, 3 to the left, and 4 divided by 2 units up, which is 2 units up. So 1, 2 units up. So these are our 3 points for our image triangle. So if we draw lines between them, this is our third triangle. Now make sure that in the exam you have precise positioning of the points and not assumptuous or like inaccurate like I'm doing because I'm using an iPad. So in the actual exam, use sharp pencils to show if you're drawing at mid coordinates. For example, over here, where it's not -2 and it's not -3, but it's -2.5 for the x coordinate. So for these, always make sure that it's precisely and clear that the point is on to -2.5. Now B says that a shape P is enlarged by scale factor 3 to give shape Q, and shape Q is then enlarged by scale factor 2 by 5 to give shape R. The area of shape P is 10 centimeters squared. Calculate the area of shape R. So the scale factor P, if the scale factor that converts a line on P to the line on Q is equal to 3, this means that the area scale factor would be equal to K1 squared, which is equal to 3 squared, which is equal to 9. This is because for any scale factor, K represents lengths. So i.e., if we multiply any length on a shape by K, the scale factor, we then get the corresponding length on the other shape that is similar to it. Now K square represents area, which means that if you have the area of one shape and we multiply by K square, we get the area of the similar shape that has a K scale factor. Now K cube is involved with volume. In this case, since we're using areas, we will be using K square and ignoring K and K cube. Obviously, we'll have to know K to get the value of K square, but that's it. So in this case, for K2 would be equal to 2 by 5, and K2 squared would be equal to 2 by 5 square, which is equal to 4 by 25. So in this case, one second, P times K1 square is equal to Q, i.e. the area of P times K1 squared is equal to Q. So since the area of shape P is 10 and K1 squared is equal to 9, Q is equal to 90. Now Q times K2 square is equal to R, and since Q is equal to 90 and K2 squared is equal to 4 by 25, we get the value of R, which is equal to 14.4. And this in turn is our final answer. Now 3a says that c is equal to a quarter of x times y squared. I part says to find c when x is equal to 5 and y is equal to 8. So c is equal to a fourth times x, and since x is 5, this is equal to times 5 times y squared, and since y is equal to 8, y squared is equal to 8 squared. So the answer for this is equal to 80. And this goes over here. Now our II answer says to find the positive value of y when c is equal to 15 and x is equal to 2.4. So c is equal to, there we go. So c is equal to a quarter of x times y square, which means that when c is equal to 15 is equal to a quarter of x times y square, and x is equal to 2.4, and y square remains as y square since we don't know what the value of y or y square is yet. So y square would be equal to 15 divided by 1 by 4 divided by 2.4, which is equal to 25. Now if we take this, I think I messed up. It should be y square is equal to 25 and y is equal to the positive square root of 25. This is because we want the positive value of y and not any value of y. So y is equal to 5. Part B says to write as a single fraction in its simplest form 4 divided by x minus 1 minus 3 divided by 2x plus 5. So for this we have a simple rule. We first multiply the numerator of the left fraction by the denominator of the right fraction. So we multiply 4 with 2x plus 5. So 4 times 2x plus 5. Then we see the symbol between the two fractions. So in this case it's a negative symbol, therefore we subtract. Then we multiply the denominator of the left fraction by the numerator of the right fraction. So x minus 1 by 3, and we divide this by multiplying the two denominators. So x minus 1 and 2x plus 5. So in this case 4 times 2x is equal to 8x, 4 times 5 is equal to 20, and this is subtracted by 3 times x, which is minus 3x, and it's also subtracted by 3 times negative 1, which is equal to positive 3. And we divide this by x minus 1 times 2x plus 5. Now this is equal to 5x plus 23 divided by x minus 1 and 2x plus 5. Since it cannot be simplified any further, I'm going to write this as our final answer. Now C says to expand and simplify the fraction below. 2x plus 3 times 4 minus x times 4 minus x. So for this, since there's a rule that a minus b the whole square is equal to a square plus b square minus 2ab, this means that we can convert 4 minus x squared to be 16 plus x square minus 8x. Now if we just erase this and multiply this new fraction, this new bracket actually by 2x plus 3, since this is still carried over, 2x plus 3. We can now first multiply 2x with these three terms over here, with these three terms, to get 2x times 16 is equal to 32x, 2x times x squared is equal to 2x cube, and 2x minus 8x is equal to negative 16x squared. Now with the first part done, we can now move on, to the second term of 2x plus 3, which is equal to 3. And we can multiply 3 with these three terms over here. So 3 times 16 is equal to, it's equal to 48. 3 times x square is equal to 3x square, and 3 times minus 8x is equal to negative 24x. And our final answer would be equal to 2x cube minus 13x square plus 8x plus 48. And this would represent our very final answer. Sorry, I think I brought 16x along by mistake. This remains back there. And I'll convert this to blue since I give out my answers in blue usually. And on that note, I'll also write the working of the previous steps in black, since black is usually how I give my workings. There we go. Next, for D says to simplify y to the power of 8 divided by 16x to the power of 16 and its fraction to the power of negative 3 over 4. So there's a rule with fraction and exponents that if you have a divided by b to the power of negative x, this is equal to the reciprocal of a by b, which is equal to b by a to the power of x. So in this case, y to the power of 8 divided by 16x to the power of 16 and to this to the power of negative 3 over 4 is equal to 16x to the power of 16 divided by y to the power of 8 to the power of positive 3 over 4. Now with that done, we can now apply 3 by 4 on these two terms separately, since this is equal to 16x to the power of 16 to the power of 3 by 4 times y to the power of 8 to the power of 3 by 4. So let's first attack the denominator. Now there's another exponent rule wherein x to the power of a to the power of b is equal to x to the power of a times b. So in this case, y to the power of a to the power of 3 by 4 is equal to, y to the power of 8 times 3 over 4, and this would represent 6. Now 16x to the power of 16 by 3 to the power of 3 over 4 can again be further broken down as 16 to the power of 3 over 4 times x to the power of 16 to the power of 3 by 4. For this latter term over here, this term, we can do the same rule as we did with y. since x to the power of 16 to the power of 3 by 4 is equal to x to the power of 16 times 3 by 4, which is equal to x to the power of 12. So in this case, x to the power of 12. Now, for the bottom part, 16 to the power of 3 by 4 is equal to, one second, I'll re-add that again before I give an explanation. Anything to the power of a over b is equal to the b root of x to the power of a. So in this case, 16 to the power of 3 over 4 is equal to 4 root 16 to the power of 3, which is equal to 2 to the power of 3, which is equal to 8. So in this case, we can replace 16 to the power of 3 by 4 with 8. And our final answer would be equal to 8 times x to the power of 12 divided by y to the power of 6. Now question 4 says that Gianu records the time in seconds that some cars take to travel 195 meters. The box and whisker plot shows this information. For any box and whisker plot, there are many key components. I'm not sure if there's 4, I need first write them down. The first is these two lines on the very ends. This left line represents the minimum value. I'll use a thinner font maybe. This represents the minimum value and this represents the maximum value of the data range, i.e. the smallest and biggest value respectively. Now this line over here represents the 25th percentile, i.e. what numbers in the 25th percentile. This middle line that's in the middle of this box is the 50th percentile, which is equal to the median. And this line over here is the 75th percentile. Now with all this in mind, there's one rule that matters. The IQR, i.e. the interquartile range, is equal to the 75th value minus the 25th value. So in this case, the A part I says to find the median time, and this is equal to the line in the middle of the box. And so as you can see, the corresponding time would be equal to, if each division is equal to 1 divided by 5, then a half a division would be 1 divided by 10, so 0.1. So 9 plus 0.2 plus 0.1 is equal to 9.3, and this is our A answer. Since as you can see, this value is 9.2, this is 9.4, and the middle of these two values is 9.3, which is where our median lies. Now II says to find the interquartile range. So for this, we find the 25th and the 75th percentile. Our 75th percentile is equal to 11.6, and our 25th percentile is equal to 8.2. So the interquartile range is equal to 11.6 minus 8.2, which is equal to, 3.4. I'm going to go back to my thicker font since I'm more accustomed to that. Now part triple I says to find the difference between the average speed of the fastest car and the average speed of the slowest car. So in this case, let's first write our values of speed. The formula for speed. Speed is equal to distance over time. Now, since this graph above shows us the values of time that it takes for some cars to travel 195 meters, this means that this value, 195 meters, is a fixed distance. So this would be equal to 195 divided by the time that it takes each car to travel that 195 meters, t. Now, since speed is equal to something divided by t, this means that when t decreases, speed increases, and vice versa. So speed and time are inversely proportional. This means that the fastest car will have the smallest time, and the slowest car will have the fastest time. So, the average speed of the fastest car would be equal to 195, that's a distance, divided by the smallest time, i.e. the minimum value. So as you can see, the minimum is equal to the left line. So the left line lies at 6. So the time that it takes the fastest car to travel 195 meters is 6 seconds. So 195 divided by 6, which is equal to 32.5 meters per second. And to convert meters per second to kilometers per hour, since that's what the question is asking for, let's first look at this in a different way, this fraction. So 195 divided by 6 is equal to, if drawn above, 65 meters traveled in 2 seconds. Now if we convert seconds to hours, for that we have to multiply by 1 by 1600, sorry, 1 by 3600. So we divide a second by 3600 to convert it to hours. And to convert meters to kilometers, we divide by 1000. So when we do this, dividing something by 1000 for the numerator and dividing something by 3600 for the denominator, what we're essentially doing is, we are multiplying it by 65 by 2 times 3600 by 1000. So this constant 3600 by 1000, i.e. 3.6, this value, this constant, when multiplied to a value in meters per second, converts it to kilometers per hour. So in this case, the fastest speed of the car in kilometers per hour would be equal to 65 divided by 2 times 3.6, which is equal to 170 kilometers per hour. And our slowest car would have the longest time. So we take the maximum value. So the distance is the same, 195, and the largest value, as you can see, the rightmost line, that is lies at 13. So it takes our slowest car 13 seconds to travel 195 meters, which is equal to 15 meters per second. Now this, when multiplied by 3.6 to convert it to kilometers per hour, is equal to 54 kilometers per hour, and 117 for our fastest car. Now the difference between these two, difference is equal to 117 minus 54, which is equal to 63. Now if we move this to our side, now B says that Matilda records a distance that 80 different cars can travel with a full tank of fuel, sorry. The table shows this information. I says to write down the class interval that contains the median. So since there are 80 different cars, this is an even number, which means that the median lies not in one value but in two particular values. It is equal to the number of cars divided by 2, that place, and the same number of cars divided by 2 plus 1 place. So in this case, 80 divided by 2 is the 40th place and the 41st place. So the average of the 40th value and the 41st value is equal to the median. So in this case, 7, our goal is to add up values to reach the 40th and 41st value. So since this range shows the first 7 cars, the median does not lie in this value. Now since over here at this point there's 20 cars in total that are within this range, this also does not fall within the median, therefore this is also wrong. Now 20 plus 19 is equal to 39, so this range has 39 cars and this also does not fit the median. Now if we add this range over here, this is equal to 39, which means that the 40th and the 41st car both lie within this range of 420 to 450, which means that the class interval that contains the median is 420 less than D less than equal to 450. Since in this last value, the 40th car and the 41st car in ascending order lies, and these two cars are what represent the median, since their values when added and divided by 2 give you the median itself. Now for the mean, when you have these class intervals rather than fixed values for distance, we take the average of the two numbers on the sides when finding mean. I'll explain what this means later. So let's first find the average of these two numbers for all of these particular values. So the average of 250 and 300 is 275. The average of 300 and 400 is 350. The average of 400 and 420 is 410. The average of 420 and 450 is 435. And the average of 450 and 500 is 475. Now with these values, to find the mean, we multiply this upper value by the frequency for all these. We then add up all these values to get our numerator for the mean. And our denominator is simply the frequency. So our mean is equal to the frequency times the values, like the distance itself, divided just by the frequency. So in this case, this would be equal to, this is a big number by the way, so just don't be alarmed. 1 second, sorry. 275, which is our top value in the left, times 7 plus 350 times 13 plus 410 times 19 plus 435 times 21 plus 475 times 20. Now this divided by the frequency, which is equal to 80, gives you our mean. So this in turn is equal to 32,900 divided by 80, which gives you a value of 411.25. So let me just write that down, 411.25. A histogram is drawn to show the information in the table. The height of the bar for the interval 250 less than d less than equal to 300 is 2.8 centimeters. Calculate the height of the bar for each of the following intervals. As you can see, the class difference is different for each of these different values. The class difference is equal to the upper bound minus the lower bound. So 300 minus 250 is equal to 50. 400 minus 300 is equal to 100. 420 minus 400 is equal to 20. 450 minus 420 is equal to 30. And 500 minus 450 is equal to 50. Sorry, I wrote 45. It should be 50. Since these different class intervals are different, this means that to find the height of each bar in the histogram, we divide the frequency by the class width. So in this case, if I just erase all this for a second, for the first value, the frequency divided by the class width is equal to 7 by 50. The second one is equal to 13 by 100. The fourth is 19 by 20. The fourth one is 21 by 30. And the fifth one is 20 by 50. Now, once again, it says that the height of the bar for the interval 250 less than d less than equal to 300 is 2.8 centimeters. So for this, 250 less than d less than equal to 300 is 7 by 50. This is the height in like units basically. And this times the constant k, and this constant k would be the same for all other bars, is equal to 2.8. So k is equal to 2.8 divided by 7 divided by 50, which is equal to 20. So any histogram height essentially times 20 would represent the height of the bar in centimeters. So in this case, let's first take it for 300 less than d less than equal to 400. The histogram bar height would be equal to 13 by 100. So 13 by 100 times k is equal to 13 by 100 times 20, which is equal to 2.6. Now for the second bar, 400 less than d less than equal to 420, that's equal to 19 by 20. So 19 by 20 times k, which is equal to 19 by 20 times 20, which cancel off to produce 19. And 420 less than d less than equal to 450 in turn would be equal to the height of the histogram for 420 less than equal to d less than equal to 450, which is 21 by 30. 21 by 30 times k is equal to 21 by 30 times 20, which is equal to 14. This is our third value. Now Ivy says that 2 of the 80 cars are chosen at random. Find the probability that with a full tank of fuel, one of the cars can travel more than 450 kilometers and the other car can travel not more than 300. This means that we first choose 2 of the 80 cars. So let's first find the odds of finding a car that can travel more than 450 kilometers. As you can see by this data, let me first erase this to make it more clear to analyze. Okay, no, I can't because this includes our A answer. There we go. The number of cars that can travel more than 450 kilometers is equal to all these cars, which is equal to 20 cars only. And all these cars over here travel less than 450 kilometers. So that 20 cars out of 80 that can travel more than 450 kilometers, which means that the odds of picking a car out of the 80 cars, picking a car that can travel more than 450 kilometers, the odds of that is equal to 20 by 80. Now, since this says find the probability that with a full tank of fuel, one of the cars can travel more than 450 kilometers and the other car can travel not more than 300, this means that we multiply our two probabilities. This and means that we have to multiply, and or means that we add two probabilities. That's a trick that you can use in your examinations. So the odds that the other car can travel not more than 300 kilometers, let's see it again. If we erase this but use the same idea, one second. if this is where 300 lies, not more than 300 is equal to 7. Since only 7 cars can travel not more than 300. That's all these cars over here travel more than 300 kilometers. So this is equal to 7 by not 80 but 79, because one car is lost, which is this car over here. This very car is lost from the pile, since when we select the second car, there are 79 cars left that are unselected. So this is equal to 20 by 80 times 7 by 79, which is equal to 7 by 158. This is our final answer. Now 5a says that P is the point 1 comma 7, so 1 comma 7, and Q is the point 5 comma negative 5. I part says to find the vector PQ. This means that we have to add something to 1 to get 5. So the x value would be equal to 5 minus 1, which is equal to 4. So 4 goes on the top here. And our y value is equal to the qy value, which is negative 5. Negative 5 minus the y value of the x coordinate, which is equal to 7. This is equal to negative 12. So that goes in the bottom. The reason that this is so is explained in part 2aii. Now 5aii says to show that OP, the magnitude of the vector OP, is equal to the magnitude of the vector OQ. So the vector OP itself is equal to 1, since it moves by 1 unit to the right and 7 units upwards. So 1 unit to the right and 7 units upward. This is equal to OP. Therefore, the magnitude of OP would be equal to essentially the hypotenuse. If we imagine a line that goes straight from O to P directly, this length, and if we model a triangle based on this, where this is 1, since it moves 1 unit to the right and 7 units upward, the hypotenuse h, which represents the magnitude, would be equal to a square plus b squared, the square root of that. So this is equal to 1 square plus 7 square, which is equal to 50, the square root of 50. That's equal to the magnitude of OP. Now OQ is equal to, if I erase all this over here, 1 second, OQ moves 5 to the right and 5 units down, so 5 and 5. Now 5, negative 5, so the magnitude of OQ would be equal to 5 square plus negative 5 square, which is also equal to negative 50. Since these two values are the same, this means that OP is equal to OQ. You can write a statement in the bottom that says that since the square root of 50, which is equal to OP, is equal to the square root of 50, which is equal to OQ, they are both the same. So I'll just write in this case, both is equal to negative 50, therefore the same. Now III says that PQ is a chord of a circle with center O. Calculate the circumference of this circle. So if we look back up and erase all our previous work, sadly, we have to imagine PQ as a chord, which means that it's a line that connects 2 points in the circumference of a circle. And the circumference itself is, if we imagine it as something like this over here, it continues on. Now since the center of the circle is O, and since OP is equal to OQ as established in II, this means that the radius is equal to OP and OQ. Since P and Q both have to line the circumference for the line PQ to be a chord, since a chord connects two lines on the circumference, and since P and Q are both points on the circumference, the distance between any point on the circumference and the center of a circle is a radius, which means that OP and OQ are both radii, i.e. the plural of radius is the plural of radius of the circle. So to calculate the circumference, C is equal to 2 times pi times r, which is equal to 2 times pi times, 1 second, r. And since the radius as established in II is equal to the square root of 50, since the radius is equal to OP and OQ, and these values are both equal to the square root of 50, this means that our final answer is equal to 2 pi root 50, and when rounded, this gets us a value of 44.4 rounded to 3SF. Now IV says that PQ is now the diameter of a different circle with center R. And the question asks you to find the coordinates of R. So if we draw this imagination of a circle and make our own new imagination, where PQ is the diameter of a circle like this essentially. Now since the midpoint of PQ is now the center of the circle, this means the coordinate of R, the center, would be the midpoint of the line PQ. Since the midpoint of the diameter is the center of the circle. So since P is equal to, what is the coordinates of P? Let's look up. 1, 7 and Q is equal to 5, negative 5. The midpoint would be the coordinate of P, the x coordinate of P, 1 plus the x coordinate of Q, 5 divided by 2, the comma, the y coordinate of P, 7, plus the y coordinate of Q, negative 5 divided by 2. Now this in turn would be equal to 6 divided by 2, which is 3, and that's for the x coordinate, and the y coordinate is 7 minus 5 divided by 2, which is 1. So our IV answer is 3, 1. Now 5AV asks you to find the equation of the perpendicular bisector of PQ and to give your answer in the form y is equal to mx plus c. So for perpendicular bisectors, we need two pieces of information. We need, one second, we need the center of the line, and we need the gradient of the line. Now the center of the line is equal to the midpoint, and the midpoint is already established to be, as shown in 5A IV, 3, 1. This means that the perpendicular bisector meets PQ at the center 3, 1. I'll just write as midpoint for now, since the symbol for gradient is also M, which might make things confusing. Midpoint. Now M1, which is the gradient of PQ itself, is equal to y2 minus y1 divided by x2 minus x1. So if we treat Q as 0.2 and P as 0.1, the y coordinate of Q would be y2 and the y coordinate of P would be y1. So the y coordinate of Q is negative 5. So y2 minus y1, where y1 is equal to 7, divided by x2 minus x1, where x is 5 and y is 1. So this is equal to negative 12 divided by 4, which is equal to negative 3. Now M2 is equal to, the fixed value is negative 1 divided by the value of M1, which is equal to negative 1 divided by negative 3, which is equal to 1 over 3. Now we have y is equal to 1 over 3 x plus c. This is the equation of the perpendicular bisector. So now we need to find c. C is equal to y minus 1 by 3 x. Since if we move 1 by 3 x to the left hand side, we get this value. And since we have a point on this perpendicular bisector, which is the center, so since the center is a point that is shared by both the lines, this means that this center would follow the equation of both the lines, which means that we can substitute the value of y with the midpoint value of y, which is 1, and we can substitute the value of x with the midpoint value of x, which is 3. These cancel off, which is equal to 1 minus 1, which is equal to 0. Therefore y is equal to, if we go this way, y is equal to 1 by 3 x plus c, where c is equal to 0. So this cancels off, and our final answer is y is equal to 1 over 3 x. Now B says that the position vector of A is A and the position vector of B is B. The position vector, let me remind you again, is the position of A relative to O. Now M is a point on AB such that AM to MB is equal to 2 is to 3. So if we imagine, like, we draw random lines between, if we make a center O and we make two centers A and B, O to A, this vector is equal to A, and O to B, this vector is B. Now M is on a point AB, so if we draw a line, imagine this AB. Let me first erase something, sorry. There we go. So M is on point AB such that AM to MB is equal to 2 is to 3, which means that we can imagine this as being 2 and this as being 3. This is the ratio of AM to MB. Now the question asks you to find, in terms of A and B, the position vector of M. So the position vector of M would be equal to OM. Now we can find OM by going to OA first and then going to AM. Since if I draw this exact same triangle again in a different way, if this is O and this is M, to get to M, rather than going straight to M, we can first go to A, and from A we can go to M. Since in the end, no matter what approach we take, either going from O to A then A to M, or going from O to B and then B to M, our final answer, i.e. the value in terms of A and B, should always remain the exact same. The coefficients would not change regardless of what approach you take to reach M from O. So in this case, if we take OA plus AM, since OA is equal to A, one second, I'll use this hat symbol for now, plus AM. So AM is equal to, as you can see, 2 by 2 plus 3 times AB. Since if the ratio of AM to MB is equal to 2 is to 3, this means that we can treat AB as 2 plus 3. Since this 2 and this 3 both contribute to 2 plus 3, which is AB. So the ratio of AM to AB is equal to 2 is to 5. And we have the value of AB since AB is equal to, one second, let me first plus 2 is to 5 by AB, which is equal to AO plus OB. Since, as I said before, to get from A to B, we can go from A to O, then O to B. We can use intermediaries to get to the final destination. Since in the end, if our math is right, our coefficients will always remain the same irregardless. So in this case, this would be equal to A plus 2 by 5, A which is negative A, plus OB which is positive B. So this is equal to 3 by 5A plus 2 by 5B. And this is our final answer. Let me just select this text, make it blue, and move it to the side over here. There we go. Now 6 says that the diagram shows the positions of two lighthouses A and B, both C and a harbor H. C is due east of B. Due east means that C and B are in 90-degree angles. So if I just draw a line like this, if this is north, this is B, and this is C, they meet at 90-degree angles, which means that the bearing of C from B is exactly 090 degrees. So the A part says to find the bearing of the harbor from both C. So the question asking you to find this angle essentially. Since the harbor is here and C is over here, so the bearing of the harbor from C means you have to find the angle from C that gets you to H. So in this case, one second, if you imagine the north line as again the straight vertical lines that are common amongst all lines, and the bearing of B from C is 90 degrees, which means that this too is 90 degrees. Since if the bearing of C from B is 90 degrees, the bearing of B from C in turn would be 270 degrees, which means that they both meet at 90-degree angles. So since this is 180 degrees and this is 90 degrees and this is 25 degrees, and the sum of all angles in the circle will add up to 360 degrees, this means that this angle over here would be equal to 360 degrees minus 180 degrees minus 90 degrees minus 25 degrees, which would be equal to, one second, 360 minus 180 minus 90 minus 25, which is equal to 65 degrees. And so the bearing of the harbor from C would be equal to 180, since we travel 180 degrees and then an additional 65 degrees to get to this line, which is what connects H from C. So 180 plus 65, which is equal to 245 degrees. Now BI says to show that the angle CBH is equal to 100 degrees. One second, let me first erase this, erase this, erase this, erase this, and erase this. I'll just erase it all here for now. Show that angle CBH. So CBH would be equal to this here, this angle over here. Now since all angles in a triangle add to 180 degrees and CBH is a triangle and we have two angles here, 55 and 25, the angle CBH itself would be equal to 180 minus 25 minus 55, which are the other two angles in this triangle, and this is equal to 100 degrees. Now the BII says to show that BH is equal to 13.7 kilometers. Now this in turn makes use of our sine law, which says that sine A, where A is the angle, divided by A is equal to sine B divided by B, where B is length, where this A and small a and small b represent lengths, while capital A and capital B represent angles. So in this case, if we treat this as side small a, its angle would be the opposite angle, the angle that it's not in contact with. So if this is B, then this would be capital B, and so forth. So using this law, if we have two angles and one side, we can find length of another side essentially. So show that BH is equal to 13.7. So sine, let's take this side with length and its corresponding angle, which is equal to, as established in 5BI, 100 degrees. So sine 100 divided by the length, which is 32 kilometers, is equal to the sine of, they want BH, so it's this length. So the opposite angle would be equal to 25 degrees. So sine 25 degrees divided by BH. So through substitution, if we replace BH with this big fraction, this means that BH is equal to sine 25 degrees divided by sine 100 degrees divided by 32. This is equal to 32 sine 25 degrees divided by sine 100 degrees. And this, when rounded, would be equal to 13.73 kilometers dot dot dot, which when rounded again would be equal to 13.7 rounded to one decimal place. Now C says to calculate the bearing of A from B. Since this is 5 marks, you know that we have to go on a journey with this C part. Calculate the bearing of A from B. So let's erase all our subsequent working so far on this. So A from B would be equal to, this angle over here. So let's write all the information we have so far. This is equal to 100 degrees. That's pretty much all the information we have. Now let's see. If we have the length BH as well, which is equal to, as stated before, 13.7. This means that for this triangle ABH, we have all three lengths. This means that we can find the cos of any angle. Since as a rule is that cos theta for any specific angle is equal to a square plus b square minus c square divided by 2ab, where small a, small b, and small c represent the three sides, and c represents the side that's opposite to theta angle. So in this case, if you're finding this angle over here, i.e. angle ABH, the cos of it would be equal to, let me write it here, cos of angle ABH is equal to a square plus b square minus c square divided by 2ab. But what is a square b and c square is our new question. Let me erase this to make it as simple as possible. Our a square and b square would represent the two sides that are connected to it, i.e. in this case 11 and 13.7. So 11 square plus 13.7 square minus the side that's opposite to it. So in this case 14 squared minus 14 square divided by 2 times a times b, and again a is equal to 11, b is equal to 13.7. We could also swap it around, a being 13.7 and b being equal to 11, and it would not make a difference since a and b are just the two sides that are connected to the angle. Those two lines, when they meet, they produce that angle itself, whose cos we are trying to measure essentially. So 2 times 11 times 13.7. So 11 square plus 13.7 square minus 14 square divided by 2 times 11 times 13.7. Now if you want to find the angle itself, angle ABH, we do the cos inverse of this gigantic thing over here. I'm going to steal that from the previous part. Wait, am I able to copy is the question. Duplicate and put that over here. Perfect. So the cos inverse of this would be 68.0. So since we have this angle over here now, let me erase these sides being marked. 68.0, And 6BI established that angle CBH is equal to 100 degrees. This means that the bearing of A from B, would be equal to 100 degrees, as shown by us traveling that much, plus 90 degrees, since this angle is equal to a right angle, which is 90 degrees, plus 68. So 90, let me erase it and restate why we got there. We have to go from here to here, and for this there are three angles that contribute to this. We have the first angle here, which is 90 degrees, our second angle here, which is equal to 100 degrees, and our third angle here, which is equal to 68 degrees. So 90 plus 100 plus 68 is equal to 258. 258. And this is our answer for the bearing of A from B. Let me just 1 second. I have to bring this down, I guess, since this is a step of working that we'll have to use to show that we understood how we got there. Okay, that disappeared, so I'll just rewrite it. 90 plus 100 plus 58 is equal to bearing. Wait, was it 58 or 68? Sorry, 68 degrees, not 58 degrees, which is equal to 258 degrees. Now D says at 1 p.m. boat C sails 32 kilometers directly to the harbor at a speed of 10 knots. Calculate the time when boat C arrives at the harbor. So if we look at this again, 1 second, sorry, I'll just erase all this again. So a boat C is over here and our harbor is over here. Now boat C travels 32 kilometers directly to the harbor at a speed of 10 knots, which, if 1 knot is equal to 1.852 kilometers per hour, 10 knots would be equal to 18.52 kilometers per hour. Since if we look at this, if we multiply both sides by 10, we get 10 knots, which is the actual speed, which is equal to 18.52 kilometers per hour. And this goes over here. So the question asks you to give this time when boat C arrives at the harbor corrected to the nearest minute. So time t is equal to distance over speed, and since our distance is equal to 32 kilometers and our speed is equal to 18.52 kilometers per hour, this is equal to 800 divided by 463. And if we convert this to what do you say, sorry, if we convert this to mixed fraction form, we get is equal to 1 times 337 by 463, which means that we do travel 1 hour and some minutes. So this is a fraction of an hour. So 337 by 463 is essentially something of an hour, a fraction of an hour. So to convert it to minutes, we multiply it by 60. 337 divided by 463 times 60, which is around 44 minutes. So the time that it takes traveling is equal to 1 hour 44 minutes. Now this plus when it leaves at 1 p.m., this means that 1 p.m. plus 1 hour 44 minutes, let me just erase this over here, is equal to 2:44, and this is when the boat reaches the harbor. So 2:44 p.m. Let's specify p.m. because if you're going to use 12-hour format, we'd have to include p.m. or a.m. to show the time of day. II says to calculate the distance of boat C to the harbor when boat C is at the shortest distance from lighthouse B. So if we look at this again, when boat C is at the shortest distance from lighthouse B, boat C is perpendicular to lighthouse B, essentially. So the line connecting both C and H, which is this line, would be perpendicular to the line connecting both C and lighthouse B when the boat C is closest to the lighthouse. So let's say our C is over here now. This is a right angle because it's perpendicular, and we have an angle. So what does the question say? It says calculate the distance of boat C to the harbor when boat C is at the shortest distance from lighthouse B. So if we have the length of BH as well, As established in the previous question, BH is equal to 13.7 kilometers. This means that if we redraw this, I'll redraw it better, sorry. We have an angle, a right angle. We have a hypotenuse, our adjacent and our opposite. What we want is the distance from the boathouse to sea. So this, we want the opposite. And we have the hypotenuse already and the angle. So if we use SOHCAHTOA, one second, SOHCAHTOA, what has O and H? So we take the first digit S, so sine. So we need to use sine in this case. If you want to understand SOHCAHTOA, I'd recommend you search a video on how SOHCAHTOA works. SOHCHTOA. Anyways, so sine 55, since 55 degrees is the angle, is equal to the opposite divided by the hypotenuse. So the opposite is equal to the distance of both sea to the it said to the harbor. In that case, we'd have to use not sine but cos. Since I saw you misread the question, and as a risk that you should not do like I did, the distance of sea to the harbor would be equal to this over here. And we have the hypotenuse, and we have the adjacent. We don't need the opposite in this case. And if we reference SOHCAHTOA, we have A and H, and we have the angle. So we'd use cos. So cos 55 degrees is equal to adjacent divided by hypotenuse, which is equal to, I'll write CH for now to represent the distance from both sea to the harbor, divided by the hypotenuse, which is 13.7. Let me make sure of that once. Yeah, 13.7. Therefore, CH is equal to 13.7 times cos 55 degrees, which when rounded is equal to 7.88. Wait, sorry, one second. 13.7 times cos 55. 7.86, sorry, when rounded to 3SF. 7.86. There we go. 7a says that a diagram shows a box in the shape of a cuboid, and the box is open at the top. I part says to work out the surface area of the inside of the open box. So if the top part is open, this means that it is not included in the surface area. So the only parts that are actually making up the cuboid are these other sides over here. So this green side, this green side, this green side, this base, this side, and this side. All this green part represents what's actually contributing to the surface area. So iPad says to work out the surface area. This would be equal to, let's do the total surface area, which is equal to 2 times LH plus BH plus LB. This formula represents the total surface area of any cuboid, where L is the length, H is the height, and B is the breadth. And let's subtract this with the open top. For now, I'll represent this as green. One second. I'll use red to show that it's not included. So this part is open and should not count towards surface area. So we subtract it from the calculations. So this is minus 70 times 30. Since this is the area of that one particular open side. So this is equal to 2 times L times H, which is length times height, which is equal to 70 times 40, plus the breadth times the height, which is equal to 30 times 40, plus the length times the breadth, which is equal to 70 times 30, minus 70 times 30. This gets us a final value of, 10,100. So if I just duplicate this, and I take this duplicate and I make it blue, and I put this as a final answer, this is what we get. Now II says that cylinders with height 20 centimeters and diameter 15 centimeters are placed in the box. Work out the maximum number of these cylinders that can completely fit inside the box. So in this case, if we can stack these cylinders up in two, since it has a height of 20 centimeters, which means that if this is a cylinder height and the box height is 40 centimeters, this means that two cylinders can be stacked on top of each other within the box. So now with that known, we should see how many cylinders can fit in the lengthwise. So lengthwise, since its diameter is 15 centimeters, this means that 15 if the length is 70 centimeters, So 15 times n, where n is a whole number, should be less than or equal to 70. So n would have to be less than or equal to 70 by 15. So n should be less than or equal to 4.666 dot dot dot. Therefore n is equal to 4, since that's the largest possible value that fits within the inequality. So 4 cylinders can fit lengthwise. Since if you have 4 cylinders lengthwise, this means that the length that they occupy is 15 times 4, which is equal to 60 centimeters. If you add one more 15 length, this will make it 75 centimeters. And since the length itself is 70 centimeters of the box, this means that the fifth cylinder would not fit. It would be outside the boundaries of the box. And the same way, if you see the breadth-wise, how many cylinders can be fit, the breadth is equal to 30 centimeters. So since 30 divided by 15 is equal to 2 exactly, this means that we can stack 2 cylinders breadth-wise exactly. So this fits perfectly without any open spaces left. So the total number of cylinders that can fit is equal to 4 times 2 times 2. Since 4 cylinders can fit lengthwise, 2 cylinders can fit breadthwise, and 2 cylinders can fit heightwise. So this is equal to 16. Our final answer is 16. Now B says that a solid bronze cone has a mass of 750 grams and the density of the bronze is 8.9 grams per centimeter cube. The ratio of the radius of the cone to the height of the cone is equal to 1:3. I says to show that the radius of the cone is 2.99 centimeters, correct to 3 significant figures. So if density is equal to mass by volume, and the volume of the cone is equal to 1/3 pi r square h, as shown in this formula over here, and the mass of the bronze cone is equal to 750 grams, and the density is equal to 8.9. This means that 1/3 pi r square h is equal to 750 divided by 8.9. And let me check if it has an exact value. It is not, therefore I'll leave it as that fraction for now. Pi r square h would be equal to 750 divided by 8.9 times 3. Since if you multiply 3 by both sides, this and this fraction cancel off, giving you pi r square h left. Now to remove pi and h, just 1 second, to remove pi we'd have to divide this by pi in this case. So r square h would be equal to 750 divided by 750 times 3 divided by 8.9 pi. Now since the ratio of the radius of the cone to the height of the cone is 1:3, this means that 3 radiuses would fit into one height. So r square times 3r would be equal to 750 times 3, which is equal to 2250 divided by 8.9 pi, which means that r cube is equal to 2250 divided by 8.9 pi divided by 3. Since as you can see, this r square and this r multiplies to produce r cube, while 3 can then be divided from like the right hand side to remove 3 as a coefficient of r in the left hand side. Therefore r would be equal to this thing over here, but square rooted, and this rounded is equal to 2.99. Now IS says to calculate the total surface area of the cone. Now the total surface area is equal to the curved surface area plus the base of the cone. Since if we draw a model of the cone over here, the curved surface area is the area of this rounded part over here, and this is the CSA, and the base, okay, that disappeared for a second, sorry, there you go, and the base is this area of the circle at the bottom. So when we add these two, we get our TSA, since that's the total surface area of the cone itself. And so since the curved surface area as shown in the question itself is equal to pi RL, where L is the slant height, and the base is equal to pi r square, this is equal to the TSA. And since we have pi, all we need to find is L. So if you imagine a cone like this, where this line is a vertical line that passes through the center of the cone, This means that, one second, if we draw a triangle that connects the center of the base with a point on the perimeter of the base, and the point connecting the point where the vertical line emitting from the center of the base reaches up and touches the tip of the cone, and we draw a third line over here, we get a Pythagorean triangle. Since these 2 points, this point, one second, it's not being drawn, this point and this point are both on the base, which means that they are horizontal, which means that any vertical line drawn will be perpendicular to this horizontal line. Therefore, this is a right angle over here. And so this side, one second, let me zoom in. This side over here represents our radius, since that's the radius of the base of the circle itself. Sorry, base of the cone, not the base of the circle, the base of the cone. And this line represents our height, which is equal to 3r. So this is our slant height, which is the length of the side of the cone essentially. So L is equal to r square plus 3r, the whole thing squared. This is equal to 9r square plus r square, which is equal to 10r square. Now I'll just sub this in, one second, make it black. So this times r times pi plus pi times r square. Now let's sub in a value of r, which is 2.99. So this is equal to pi times 2.99 times 10 times 2.99 square. This plus pi times r square, which is equal to 2.99 square. When we round this, we get a value of approximately 117 when rounded to 3SF. One second, sorry. 117. Let me just write this text. One second, sorry. I'll just write this text in black to make it more clear. There we go. Now 8a says on the axes, sketch the graph of y is equal to x squared plus 7x minus 18. On a sketch, write the values where the graph meets the x-axis and the y-axis. So let's first find the coordinate points, i.e. the points where the graph would meet the x-axis and the y-axis, the roots and the y-intercept. So when x squared plus 7x minus 18 is equal to 0, this means that the value of x is equal to negative b, which is negative 7, since this is equal to ax squared plus bx plus c is equal to 0, c is equal to negative 18, b is equal to 7, and a is equal to 1. So a is equal to, x, the roots of the equation are negative b plus minus the root of b square minus 4ac. So 7 square, which is 49, minus 4 times a, which is 1 times c, which is negative 18, divided by 2 times a, which is 2 times 1. So this is equal to negative 7 plus minus, 11 divided by 2. So this gets us a value of 2 and negative 9. So our two roots are 2, 0 and negative 9, 0. Now when x is 0, what is the value of y? I.e. what is the y-intercept? That is equal to c itself. So our third point that matters is equal to 0, c. And since c is equal to negative 18, this means that our c point is equal to 0, negative 18. Now with these 3 points, let's first note these down. So 2, 0, negative 9, 0, and 0, negative 18. As you can see, to connect these 3 points, we'd have to draw a curvy graph that goes like this rather than like this. Therefore, our graph should look somewhat like this U-shaped graph essentially. Now the graph should turn at around this region, since it should turn at the midpoint of negative 9 and 2. So that's equal to negative 3.5, that is the x coordinate of the turning point of the graph itself. So it should be around this region. The mark scheme says that the turning point should just be within the third quadrant. So if you're able to demonstrate that you understand that the turning point is within this region over here, you get the mark. This is because if this is one root and this is the other root, the midpoint of these two roots, so let's say this is the midpoint, this is where our turning point lies. So in this case, let's assume our turning point is over here. So let's connect all these lines together. Sorry, I should make it more curvy. Yeah. This is how our graph should somewhat look like. Our turning point is clearly within the third quadrant, and we have marked all the points of interest, which is negative 9, 0, 2, 0, and 0, negative 18. Now BI says to find the derivative of y is equal to x squared minus 3x minus 28. So for this, dy by dx, which is a symbol of the derivative of y, is equal to, for any value ax to the power of n, the derivative is equal to, we multiply n times a times x to the power of n minus 1. This is a very critical formula that you must memorize for all examinations that you do with math. So for now we have x square. So x square, when fit into the format ax to the power of n, is equal to 1x to the power of 2. So the derivative would be 2 times 1 times x to the power of 2 minus 1. Because if 2 is n, then 2 gets multiplied with 1 and 2 gets subtracted on its own. So this gets us a value of 2x1. So our first term becomes 2x. And remember, the derivative acts on each of these three terms, x squared, minus 3x, and minus 28, independently. So let's take our next term, which is negative 3x. This is to the power of 1. So we multiply 1 by negative 3. So negative 1 times 3 times x to the power of 1 minus 1. And since 1 minus 1 is 0, and anything to the power of 0 is just equal to 1, this means that we can just cancel off this, because minus 3 times 1 is just minus 3. So our second term becomes minus 3. And for our third term, minus 28, as you can see, there's no value of x itself. This means that the derivative is equal to 0. So if you try to find the derivative of y with respect to x for any term that does not have x, so in this case a constant like 28, the derivative just becomes 0. Since there's nothing to like find the derivative of, because x is not within this term itself. So our final answer is 2x minus 3. And our II question is to find the coordinates of the turning point of y is equal to x squared minus 3x minus 28. So we can use our derivative function. Since at the turning point, the derivative, which represents a gradient essentially, is equal to 0. So our m is equal to 0. And since 2x minus 3 gives us the value of m at the x coordinate which is given, this means that if we have 2x minus 3 is equal to 0, the value of x is equal to the x coordinate of the turning point. So that shows us the x coordinate of the point where m is equal to 0, where the gradient is horizontal, and when the gradient is 0, that is where the turning point lies. So x is equal to 0 plus 3 divided by 2, which is equal to 1.5. Now, with that in mind, we can now sub in the value of x into y is equal to x squared minus 3x minus 28. Since y is equal to x squared, which is 1.5 square, minus 3x, which is minus 3 times 1.5 minus 28. And this is equal to minus 30, minus 30.25. So our x value is 1.5 and our y value is negative 30.25. Now C says that the line y is equal to 5 minus 2x intersects the graph of y is equal to x squared minus 3x minus 28 at point P and point Q. Find the coordinates of P and Q, and you must show all your working and give your answers correct to 2 decimal places. So if I draw a very, very rough sketch to give you an understanding of how this would work, this is negative 2x, y is equal to 5 minus 2x, and 1 second, x square minus 3x minus 28. This means that at these 2 points, the points where these two graphs meet, the x value and the y value are both the same, which means that at these two values, the y values are the same and the x values are also the same. Sorry, one second. And the x values are also the same. This means that if you put the value of x into x squared minus 3x minus 28, you will get the same value as when you put x into 5 minus 2x. Since both of these will get you the value of y itself, and y is the same for both of these at these 2 points, which are the points P and Q. So to get this, let's first assume that x squared minus 3x minus 28 is equal to 5 minus 2x. This identity essentially is true for points P and Q. So the x coordinates and the y coordinates of P and Q would both satisfy this identity. So if we move 5 and minus 2x to the other side, we get x squared minus 3x plus 2x minus 28 minus 5 is equal to 0. This is equal to x squared minus x minus 33 is equal to 0. Now let's find the roots of this. X is equal to, if we represent this as ax squared plus bx plus c is equal to 0. X is equal to negative b, which is negative 1, plus minus the b square minus 4ac, which is equal to negative 1 square minus 4 times a, which is 1, times c, which is negative 33, divided by 2 times a, which is 1. This is equal to 1 plus minus the square root of, 1 square minus 4 times 1 times negative 33, which is equal to 133 divided by 2. So now we have two values of x. So these are the x coordinates. So in the sense that x, when x is equal to 1 plus square root of 133 divided by 2, or when x is equal to 1 minus square root of 133 divided by 2, and you sub the value into any one of these two identities, either 5 minus 2x or x squared minus 3x minus 28, not identities, sorry, equations. If you sub in these two roots, any one of these two roots, into the equations 5 minus 2x or x squared minus 3x minus 28, you get the same value, which is equal to the value of y at that point. So let's say a bullet point here, when x is equal to, let's round these two values first, 1 minus 33, 6.27 and minus 5.27. So x is equal to 6.27 rounded, y is equal to, let's take the simple equation, which is equal to 5 minus 2x. Since there's no squares involved, it's just simple multiplication and subtraction. So y is equal to 5 minus 2. Let's take our actual value of x in this case, so as to not risk any intermediate errors, which is when you round up values that are also contributing to the final value. So if you sub in 6.27 into this, the marks scheme might not support this in future questions that you might get, because they might expect you to use the actual value of x, the real value, which is equal to not 6.27 but 1 plus square root of 133 divided by 2. And this, when rounded, is equal to 5 minus 2, 1 plus square root of 133 divided by 2, negative 7.53. So let's put our first point, 6.27 and negative 7.53. Over here, rounding is fine because this is our final answer. We can round up our final answers, but for intermediate answers, let's not round them. So when x is equal to negative 5.27, this is again a final answer, since we give our value of x itself, negative 5, why is it not writing, 5.27, y is equal to 5 minus 2, 1 minus the root of 133 divided by 2, which when rounded gives us a value of 15.53. Because the question asks to give you answers rounded to 2 decimal places, not 3SF. So make sure all your answers are in 2 decimal places. So 15.53. Now question 9a(I) says to give the value of f3. This means that when you sub the value of 3 into x of fx, what do you get? So this is equal to 4 times you're subbing in 3 as the value of x. So 3 plus 1, which is equal to 13. So I is equal to 13. Now II says you first sub in the value of, you get the value of f3, which is equal to 13, and then you sub 13 itself into g. Since g f3 is equal to g of f3, so you sub in this value that you get into the value of x itself. So this is equal to 6 minus 2, 13, which is equal to 6 minus 26, which is equal to negative 20. Now B says to find the g inverse. So if we write the g equation itself, 6 minus 2x, and we first equate this to equal to of y. Now let's make x a subject. Let's separate x from 6 and minus 2. So let's first move 6 to the other side. So minus 2x is equal to y minus 6, and x is equal to y minus 6 divided by minus 2, which is equal to 6 minus y divided by 2. Since we are just multiplying both sides by negative 1. This is a multiplication and not x. It's multiplying by negative 1. Now that we have the value of x, we can now say that g inverse of x is equal to this itself, but substitute y for x. So 6 minus x divided by 2. This is our final answer. 6 minus x divided by 2. Now C says to find x when fx is equal to g 2x minus 7. So fx is equal to 4x plus 1 as shown above, and g 2x plus 7 is when you sub in 2x minus 7 into x over here. So this would be equal to 6 minus 2, and this is where x would have been, but now we have 2x minus 7. So this is equal to 6 minus 4x plus 14, which is equal to 20 minus 4x. Now 4x plus 1 is equal to 20 minus 4x. So let's move in the 4 here and let's move in the 1 away. 8x is equal to 20 minus 1, which is equal to 19. X is equal to 19 divided by 8, which is equal to 2.375. Now D says to find the value of h(h2). Again, this would be equal to h(h2), where you sub in the value of h2 into h again to get the final answer. So if h2 is equal to, let's see h, what is h? 3x minus 2. So 3, and since this is where x would have been, but we sub in 2 in this case, this is equal to 3 to the power of 0, which is equal to 1. Now we sub in this value of 1 into h itself again, because h2 is equal to 1. So h1 would be equal to 3 to the power of 1 minus 2, which is equal to 3 to the power of negative 1, which is equal to 1 over 3 to the power of 1, which is equal to 1 to the power of, sorry, not 1 to the power of, it's 1 divided by 3 to the power of 1, which is equal to 1 divided by 3. And this is our final answer, 1 divided by 3. Now E says to find x when h inverse of x is equal to 10. Now for this, we'll make use of a different rule for functions, which is that h inverse of x, so the composite function made with h and its inverse would just give you the value of x itself. So if we do this sub in, since h inverse of x is equal to 10, this means that h10 is equal to x. So x is equal to h10. So let's sub in the value of 10 to x in hx. And since hx, as I said before, is 3 to the power of x minus 2, this is equal to 3 to the power of x, where x is 10 in this case, minus 2. So 3 to the power of 8. And this is equal to 6561. This is our final answer. Thank you so much for watching, and I hope you can subscribe for future videos and like this video and comment any questions that you might have. Thank you.